Okay guys, so we're going to be determining electrical load at this point as it regards single family dwelling unit. Alright, so this question goes like this: what size service conductor is required for 2000 square feet dwelling unit containing the following loads? And that is a dishwasher of 1000 VA, a waste disposal of 1000 VA, a water heater of 4500 watt, a dryer of 5500 watt, a range of 14,000, and air condition unit of 20 amps, 240 volts. All right, and we also have electric heating unit of 9600 watt. Okay, so the order in which we're going to do our calculation will entails lighting and receptacle load, fixed appliance load, dryer load, range, air conditioning, and heating unit load. All right, so just picture that in your head as it regards how you're going to determine a single load from all these appliances that is taken into consideration. Nevertheless, we're going to look at how we calculate the load for the occupancy as it regards lighting. All right, so that is very important in the steps to determine the total load connected, and how we going to finalize the service conductor size to be determined from this calculation. Alright, so we're going to take you first into lighting and receptacle loads. Lighting and receptacle loads involve occupancy load as well. And if this was not mentioned, lighting and receptacle load will also include small appliances and laundry. Alright, so let's go. Lighting and receptacle load. Okay, so that will entails our occupancy of 2000 square feet. All right, and the demand per occupancy is 3 VA per square feet. So if we times this by 3 VA per square feet, this is going to give us our occupancy for lighting. All right, so this should work out to be, all right, 6000 VA. All right, and we're going to add our dishwasher now, our laundry of, all right, so the laundry is 1500 VA. All right, for every laundry unit or appliances that we're going to utilize within this calculation. So we're gonna add that to our 6000. And the next load is our two small appliance circuit. So two small appliances, that would be 3000 VA. All right, so just add it to the other loads. Okay, so we cover occupancy for lighting and laundry and two small appliances. and this will be determined for the light and receptacle load. So all we got to do is just add. Alright, so this in total going to be alright, so we got 10,500 VA. So that is our lighting and receptacle load. I cover general loads. Alright, so we have to find the demand for lighting and receptacle. Alright, so the demand for lighting and receptacle, we normally would take the first 3,000 VA at 100%, right? So that is 3,000 VA, and then we'll take the remainder the second rather at 35% of the load. Alright, so say we know the load to be 10,500, so the remainder has to be 7,500, right? So we're going to take 35% of the remaining load. So that is 2,625. All right, that's 2,625. So we just add it to the other side. Okay, so the demand for lighting and receptacle load would have been alright, so we have 5,625. Alright, so the next step in this calculation, we're going to determine our fixed appliance load. Alright. The fixed appliance load, that includes dishwasher, waste disposal, and water heater. Alright, so we're going to write out our dishwasher, which is 1,000. We're going to write out our waste disposal, which is 1,000. We're going to write out our water heater, which is 4,500. Alright, now there's a demand per load as regards some appliances, or when you're dealing with single family dwelling unit for fixed appliance load. And we know when the load is in excess of 4 or more, then we should take 75% of that load. So at this point we have 3 fixed appliance load, so we would have determined only 100% of this load. Alright, and this part is quite simple. All we got to do is just add up the total value for the fixed appliance load. So we just take the total for this load here. So this load for the fixed appliance would have been 6,500 VA. Alright, now the next one is our dryer load. Each load requires us to find the demand. Alright, or in the category of load, when it comes to dryer load, we normally take a minimum of 5,000 VA, right, for every dryer load within the unit. Alright, so let's not forget, that's first step. The second one. Alright, so this load would have been 5,500 for the dryer load. Alright, so we are within the threshold of the demand. So we said it must be at minimum 5,000 VA or 5,000 watt. So currently our dryer load is at 5,500. So for example, if the load was 4,500, then our minimum dryer load would have been 5,000. Alright, so in this case it's 5,500. So our dryer load is equal to 5,500 watt. Alright, so we don't have to go further in our calculation. We know what the dryer load is. Alright, because they're above the demand or within the demand capacity. And then we're going to determine our range for, alright, for the fourth step. So then the range load in this question you know what a range is? A range is a electrical heating element, right? That is what you'd probably use, like a stove, an electric stove, you know, for cooking purpose. All right, so a range load is 14,000 watt. Okay, so a range is 14,000 watt, but we still need to determine the range load in this question by its demand. Alright, so we don't necessarily go ahead and calculate or add our total range load. We gotta still determine the demand for 14,000 watt power within the range load category. So I'm just going to use article 220, all right, from table 22055 for demand when it comes to range load. All right, so we have 14,000 watts for the range load, and this is a single load. All right, so it is one appliances. When we come across here, the range basically greater than what it is demand in this column here. Right, so we have column A, B, and C, and that is within the limits, where we have 3,000 kilowatt, between 3.5 kilowatt to 800 and 8 3/4 kilowatt rather, and for load greater than 12,000 watt or 12 kilowatt. All right, so this load was 1400 or 14,000 rather watt, which is 14 kilowatt. All right, so we have an excess of 2 kilowatt, and it's just one appliances. So the minimum is required here is 8 kilowatt. All right, take for example now we have 14,000 kilowatt. We should determine the first 12 kilowatt. So our demand for the first 12 kilowatt would have been 8 kilowatt. Now, from the rules within this calculation here, anything in excess of 12 should be the increased amount that is going to be added to the 8, which is a resultant of an excess of 12. All right, so that means we would have increased each demand by 5% in excess of 12 kilowatt. All right, so we're going to do that right now. So the minimum demand as it regards 12 kilowatt is 8. All right, so the minimum demand from 12. All right, so say the minimum demand in excess of 12 or 12 kilowatt greater than 12 would have been 8. Now for every kilowatt greater than 12, we should increase it by 5%, and we have 2 kilowatt in excess. So we have 2 kilowatt in excess. It should increase by 5%. So that would have been exempt the kilowatt. So say for every kilowatt we should increase by 5%. For every kilowatt greater than 12, we will increase by 5. So that would have been 2 times 5% increase would have been 10. All right, so it's 10% increase. In the demand per kilowatt. All right, so our final answer would have been 8. All right, so that 8 kilowatt, right, times 10% increase. Let's assume 8 kilowatt would represent 100% of that value. Right? And just look at a product you're marking up, what you buy it for, and then how much you're gonna increase that value by, as you know, an excess of what the amount should be. Alright, if you're looking at, you know, something as a profit or something like that. Alright, so the excess amount of kilowatt in terms of the addition and such demand value would have increased to 10%. All right, so we increase this value by 10, so that would have been 1.10. All right, since it's a 10% increase, so it would have been 8 times 1.1, and that would have been 8.8. All right, so our final demand would have been 8.8 kilowatt. All right, so that is for the range. And then the final one we're going to determine is a air conditioning unit. All right, should our fifth one. We're going to determine which load in this calculation we're going to take to determine with our total load. For in the case of air conditioning unit and heating load, these are non-incidental. Now, for this kind of load, there only can be one operating at any given time. All right, so we normally take the largest value of the load. Just think about why we do demand, because we can't run everything at any given time. Some things would be at rest at some point in time. All right, so we understand that principle. So we said for the AC or the air conditioner or the heating unit, we'd have to determine the IS of a total load. So in this question, let us determine which one is the IS. We have the air condition is 20 amps times 240 volts. All right, and that is 20 times 240, which is 4,800. All right, so we want to see which one we're gonna take with it to use for this calculation. And the next load is our electric heating load. All right, so that's electric heating. All right, so that is 9,600. All right, so we're normally gonna consider the highest value for non-incidental loads. All right, so this would have been the 9,600, because we want the load that is going to able to rather when we switch on the power at any given time, we have enough capacity to deal with the highest load within the system. All right, so we're going to take 9,600 watt. All right, so this would be the final load in determining our service size or total load. So we're going to add all the loads together. All right, so this is now our demand, our total demand. All right, so let's say we consider, all right, the heating load for calculation. Alright, so we determine this load, heating load, for our calculation. Alright, so the total demand would have been lighting and receptacle, and let's say 5,000. Remember with what we have done to determine this load, and then we have fixed appliance load, our fixed appliance load. This is 6,500. Then we have a next load, which is a dryer load, dryer load is 5,500. And then the next one, we have the range load, which is 1,400 or 14,000 rather. Alright, we could have said 14,000 watt, 14,000 VA. Alright. Okay, so the range load, we just determined the range load as not 14, my bad. So the range load would have been, so the range is 8,800. Remember, we just work out the demand, alright? So range would have been 8,800 alright, almost forgot. Alright, so remember the demand has to be included. Right, so the range is 8,800. The final load in this question is our air conditioning load, which is the highest load taken between the heating, or say the air condition or the heating load, right, which is the non-incidental load. So that load is the load we're going to use to determine the highest load in this question. Alright, so in the dwelling unit calculation, you always have either an air conditioning load or a heating load. Alright, so this is the non-incidental load. Normally you take the highest value from hydro loads. Alright, so we're gonna use the highest value, which is 9,600. Alright, remember we determined the first one as 4,800. So this load here is 9,600. Alright, so that's the fifth load. So we're going to omit the air conditioning load. We're going to take the electric heating load. So we have 8 heating load, and that is 9,600. All right. All right. And all we have to do here is add up all the loads to get the final for the total demand. Alright, so that's simple. I got to just add it up. Alright, so our final answer would have been 36,000. Alright, 025. Alright, 36,025 VA. Alright. So this would have been the final demand. Let's not forget what the question wants us to solve. Alright. In this question, we must determine the service size for the dwelling unit. So now we have the total loads, which is 36,000. We should go ahead and determine the final outcome as it regards calculating the service. All right. So now we have the VA in terms of the load. All right. Now we want to determine that in terms of ampacity. Ampacity is what we use to determine conductor size. All right. And that is the amount of current flowing within any conductor. So if we want to find I is equal to VA over our voltage, right? Voltage, right? Let's say VA represents the power, right? All right, so as simple as it is, all we need to do is just take this value here, 36, and we divide it by the supply voltage. All right. The supply voltage in this question would have been 240 watts. Okay. How do I know that? It's simple because in the AC unit we have a single phase load, which is 240 watt. All right. I don't understand why this question did not determine us in this terms of, did not give us the voltage. But you know, when we go through all the appliances, then we can ascertain what the voltage supply would have been. All right, so sometimes you do working questions and you don't get a given value. All right, but when you assess all the other variables within the questions, you can determine what that value is. All right, so we know that the unit used, or rather the dwelling unit, will be supplied by 120, 240 volts. All right, so our total supply voltage would have been, or the highest supply voltage is 240 volts. So we divide this value by 240. All right. and that would have left us with 150. 150 amps. All right, so that is the final amperage or ampacity that is required to determine the service for this dwelling unit. Now, in determining the service value, we normally take 83% for single family dwelling unit. All right, so this is a single family dwelling unit of 2,000 square feet. So we take 83% of the ampacity in determining the value for this dwelling unit. So now, this is our rules when it comes to service. All right, and it's only apply for single family unit. Multi-family unit, it does not apply. All right, in one of my example or calculation I've done, I've tried to determine the load calculation or the service for a multi-family dwelling unit. In that case, I don't need 83%. All right, but in this case here, we require to use 83% rule in determining our service conductor or single family unit. All right, so the service conductor for single dwelling unit is 83% of total load, all right? And that is 83% of 150, which is 124.5 amps, right? So 83% of 150 is 124.5, and then from that we're going to final determine the conductor size we're going to use. So I'm going to use table 310 15 B 16 in determining the size conductor. So all we have to do is just go to the table and determine this value. Alright, so 310 15 B16, we're going to determine the conductor size under the 75°C column. So when the ampacity is in excess of 100, we're going to use table 310 16 or 310 15 B16. Alright, so that value for 125 would have been 1 aught, or 125 rather, would have been number 1 kcml, right, or rather 1 AW3, Alright, so let's look at the value here. This is 130. Already gone in excess of 115. So that have been 1 AW3. Alright. So this conductor size is a size 1 AW3. So that would have been 1 AW3. Alright. So that was been your final answer for determining this service conductor. Alright, so go ahead guys, just give it a likes and subscribe, as we want to give you more content like this. Thank you.